In this video, we're going to solve other types of equations. Specifically, we're going to solve quadratics with substitution. And I might be being a little bit inaccurate when I call these quadratics, because what we're going to do is we're going to use substitution to rewrite these as quadratics. Because as you can see here, we have a quartic polynomial, a fourth degree polynomial. But what you might recognize that since this exponent on the x is twice as large as that exponent on the second term, the relationship between this and this would be the same as the relationship between a linear term and a quadratic term in a quadratic. And what I mean by that is this. If I just say, let's introduce a variable, let's let u equal x squared. And then what you have is I can rewrite that negative 11x squared as negative 11u. I can bring down my plus 2. And then here, 12x to the fourth, that could be written as 12x squared times x squared, or in other words, 12 times u, which we'll just rewrite u times u as u squared. And what I've done by introducing our u variable and letting it equal x squared is we've rewritten our quartic equation as a quadratic right here. And now we can actually solve this quadratic. So I think I'm going to do that real quick. I'm just going to solve with factoring. It's not too bad to factor. So I want two values that add to give me our middle term, negative 11u, but I need those same two numbers when I multiply them to give me 24u squared. I got that because it's the product of the first and the last term. In this case, that's going to be negative 8u and negative 3u are the values that satisfy both of those equations. And so I'm rewriting my middle term as that. And now I'm ready to group. I'm going to look at my first two terms and my last two terms. In my first two terms, it looks like my GCF is going to be 4u. Whenever I factor that out of both terms, what I'm left with is 3u minus 2. In the next two terms, there's not really a GCF, but since the term on the left is negative, I'm going to factor out a negative 1. Leaving me with 3u minus 2. And since my values in parentheses are the same, that's now my GCF, which I'm going to factor out to the front, leaving me with 4u minus 1. And now what we have is this. I have the zero product property. If this times this equals 0, that means either 3u minus 2 equals 0 or 4u minus 1 equals 0. And if I solve these two mini equations for u, the equation on the left becomes u equals 2/3, and this equation on the right becomes u equals 1/4. Well, if you didn't want to solve that whole deal with factoring, we just solved this with factoring. You could have also solved that with quadratic formula, and you should end up at the same two solutions that I have right here. Now, we're not quite done yet, so I'm going to come over here and I'm going to go in green. Actually, not yet. We've said, okay, well, u equals 2/3 and u equals 1/4, and that's all fine and dandy, but we don't really care about u. We need to find out what x is. And so in the start of the problem, we defined u as being equal to x squared. So what I now have to do is I have to say, okay, well, if u equals 2/3, that means x squared equals 2/3. And if u equals 1/4, that means x squared equals 1/4. And we need to solve both these little mini equations for x. So I'm going to take the root of both sides of this equation on the left, and I get x equals plus or minus the root of 2/3. If you were to rationalize that, you would get, what would that be? Would that be root 6/3? I'm not going to go through the steps of that right now because it's outside the scope of this video. But then over here I do the same thing. I would take the root of each side. I would get x equals plus or minus the root of 1/4, and the root of 1/4 is going to be your 1/2 right here. So we really have four solutions to this equation, and that makes sense. You'll often get that because remember we had a fourth degree polynomial. So we got plus or minus root 6/3 and plus or minus 1/2. Let's look at another example. So I would consider this equation to be more complicated than the last. But once again, if we recognize the relationship between this term and this term, we see that the exponent here is twice as large as the exponent here. And then the base matches for both of them. They both have a base of x plus 1. Therefore, what I can do is I can once again rewrite as a quadratic using substitution. To help us kind of see it a little bit, I'm gonna rewrite this term right here. We have an exponent of 2/3, but hopefully remember our exponent properties. If I raise a power to a power, if I raise that to the second power, if I raise a power to a power, we multiply exponents. So what I've done is I've rewritten 2/3 as a 1/3 exponent that's being squared. This is equivalent to this, and you'll see why I did that in just a second. I'm going to copy down my second term. And now what you see is we have something squared minus something minus a constant equals 0. You can, hopefully you're seeing a little bit more how this is in the form of a quadratic now. And so what we're going to do our u substitution with here is we're going to say, okay, here let's let u equal x plus 1 to the 1/3. By doing that, this entire value is u, so that just becomes u squared. And then we still have our minus, and this whole thing is just u, and then minus 2 equals 0. So I've just taken the x plus 1 to the 1/3 power and substituted out for u. And now I've got a little quadratic that just factors beautifully. So if I look at that, that should be u minus 2 times u plus 1. If u minus 2 equals 0, that means u equals 2. And if u plus 1 equals 0, that means u equals -1. Now, we are not quite done yet. I'm going to come up here. And so if we know u equals 2 and u equals -1, what we have to recall is that we don't care what u is. We define u to be equal to x plus 1 to the 1/3. So if that's equal to x plus 1 to the 1/3, and then this is x plus 1 to the 1/3, we have two little mini equations to solve. What I want to do here is I want to get rid of that 1/3 exponent. We can almost use the same exponent property that we used here for that. If I want to turn this exponent into a 1 with the eventual goal of solving for x, what I'm going to do is I'm going to raise each side of my equation to the 3rd power. Because you can do anything to one side as long as you do it to the other. When I raise a power to a power, I multiply exponents. 1/3 times 3 is going to become 1. In other words, all that is just to the 1st power. And that's equal to 2 to the 3rd, which is 8. Then we have x equals, once I subtract 1 from each side, x equals 7. That's one of our solutions. Let's do the same thing over here. Over here, I'm going to raise that to the 3rd power, and I'm going to raise that to the 3rd power, because when I raise a power to a power, I multiply exponents. That's going to be x plus 1 to the 1st, which I don't really have to write anything to the 1st, and that's equal to -1 to the 3rd power. -1 times -1 times -1, which is -1. And then once I subtract 1 from each side, we get x equals -2. So what we've got here is we ended up with two solutions to this. We got x equals 7 and x equals -2. If this were an exam or something, I'd always encourage you to substitute those values back in for x's and make sure they work for this equation. But for the sake of time, I'm not going to do that. But just remember, sometimes you have an equation that's not a quadratic, but using a little u substitution, if we can do that and write it in the form of a quadratic, then we can use quadratic methods to solve it.